group session. My name is Kyle Barron. I work with at Metro Research Group. I'm the lead developer here for MRD Solve, and I wanted to do just a quick study group session, and this is really just kind of a show and tell, just to show you some new features that we've got in MRD Solve. There's some of them are just kind of important changes that I wanted to go through, and then there's another piece on annotated models that is kind of a whole new, something kind of totally new that I'll just demo for you. I was originally going to just present this to the group in Metrum, just to update our people on changes in the package, and I just thought, well, let's just broadcast this on the study group website for anyone that might be interested here. So kind of the session today is not going to be really anything new in terms of like new ways to do your simulations or ways to tackle problems, but just to demonstrate some new features that I kind of hope get picked up a little bit, and it would help us in the development to get these tested and get a kind of another round of review and kind of get it some real world testing on these features. So I'll go ahead and just get started on the new features. A quick word about the version that I'm using. And this is going to be really a kind of a quote along kind of thing. So I'm using MRD Solve 7.6.9022, and this is a version that's pretty. Actually, this version I just merged in with the master on GitHub this morning. You should be able to do most of this with a version as long as you've checked out something kind of in the past week or so, maybe past 2 weeks. So a lot of this stuff is pretty new in terms of the development version. I've been kind of storing this up on a different branch, but just be aware that if you're using a version that's older than a couple weeks or so, you might not be able to do everything on this on this demo. So I wanted to show one piece here. In a previous iteration of MRD Solve, we had this is a little chunk of a control stream here where we got some parameters, clearance and volume. We're doing just a PK model. And in some of the previous demos, we've used this macro called table. And what table did is when you do a line like this on line 12, this is a way to insert another column into your output data set. The name will be CP in this line, and then the result will be the ratio of the amount in the central compartment divided by volume. That has been removed. So let me run this. When you run a code like that now, you will see an error message. The model will not compile, and so this is just totally gone. We deprecated it for a little bit. It was for like maybe 3 or 4 weeks. In the development version, it would give you a warning message. Now that's just kind of totally gone, and the reason is that this wasn't really efficient. So the table uses a C++ data structure that wasn't really efficient, and I kind of suspected that it wasn't very efficient. And then I did some benchmark, and I realized when you do this, especially when you've got a lot of things that you're tabling, and when the simulation kind of starts to get longer, that it starts to take a toll a little bit on performance. So anyways, we got a workaround. So this model works, and this is the suggested way to do this. So you can still derive something in $table, but you want to do it, just declare it as a double precision variable. So we say double CP, and that equals cent divided by V. And then you just send that CP kind of symbol to capture, and then it'll capture that. This model works, I hope. Let's run this. Here. Comes from the top. This compile works, and we can just run a little simulation from here, and you can see that this is a pretty quick simulation, or simple simulation, but we can see that we get, not only do we get the central compartment, but we get the CP variable tables in the output as well. So I thought, kind of thinking about this, I thought this table was kind of convenient to be able to do this and kind of switch around which things you had in the table step to get into the simulated output. It's nice to be able to kind of turn these on and off. And when I went to go rework a lot of those control streams that had that table step, you end up writing this a lot, and it just seems like, well, this is kind of you have to write a couple lines each time. And so we made a little shortcut to kind of accomplish the same thing that table does. And it's basically just another, this is kind of C++ lingo, what's called type def. And basically what you can do is you can say, instead of saying double, CP equals whatever you want it to be, there's a type def now called capture. And capture just, it's all it does is it creates a double precision variable for you. So it's just like using double, but when MRG-Solve sees capture in there, it'll automatically add that to your capture list. So I can compile this model and run this, and now we get the central compartment and we get the CP. So it's kind of just a quick way to label something down here in this dollar table as capture A equals 2. And you can kind of, it'll automatically appear in there. You can also do this in $main. We'll run this code. Whether it appears in $main or $table, it'll appear, but you will get a warning if you capture something from $ODE. So the variable will still get made, but you really shouldn't capture something from ODE. It really should either be defined in $main or in $table, because that's either, the main is right, it's before the differential equations advance from T1 to T2, and that's $main, and then $table is after they advance. And so what you get out of when you declare a variable in ODE, it makes sense while the system is solving, so that the value of that will make sense, but really you want to recalculate that in $table. And I think there's something in non-mem that prevents you from actually using that. You have to rename, you have to use a new variable if you kind of create something in the $des, and you have to redefine it when you do it in $error. I think it'll kind of prevent you from just using something that you kind of started in $des. And I suspect it's the same kind of deal. But this is just a kind of a convenience thing here. You can still do double C equals 4. You can still use other variables here and say, and now A is going to be 2 divided by C. But that's just a little convenience thing that we added to kind of replace that table thing. And certainly if you do see the error like this, I try to make it as informative as possible, because I know even a lot of my code was depending on that table macro. So I try to make this as informative as possible. And certainly if you're having issues with your control stream or something's not behaving properly, please do post on the issue tracker on the GitHub site, and we'll get you help. So the second topic that I had today was accessing this internal library. The last time, or I think the first time we did a webinar for the ISAP study group, we had used a package called modmrg, and that was a separate R package that all it had in it was these pre-compiled models, or at least the models would get compiled when you installed the package. And so all you had to do was load this modmrg package, and then you'd have all these models available, like these kind of generic PK models and PD models and things like that. We just put some basic stuff in there, and it's kind of handy to have it just to be able to say, yeah, just give me this PK model and have it going. And I think other simulators had a similar functionality. And I used that in the previous demonstration. That package has been deprecated, but you can still get to all those models, and I'll show you how they're all now internal to MRG-Solve, and you're going to access them in a similar way that you do kind of any other model that you're building. There's a function called modlib, and modlib just returns the path to where MRG-Solve is installed, and there's a models directory inside where that is, and all the models from modmrg are now located there in their source format. This is all internal to MRG-Solve. You can so all it does is that points to a location where these models are located. I did put in the R help question mark, so there's a help topic related to modlib, and this lists all the models that are available. There's a PK1 compartment, PK2 compartment, indirect response models, effect compartment model, Emacs model. They're all just kind of stuff that was easy to code up and people might understand kind of getting started. But basically what you can do is you can use mread and point it to one of these models just like it was sitting on your in your working directory, like that model was sitting there. And all modlib does is it passes this directory path and makes that your project. And so you can load any one of those models. So this is an indirect response to model. You can see the code from that model. And then so that was the indirect response model 2. I can do an effect compartment model, same thing. The source code is just sitting there. It'll have to compile the model, so these aren't pre-compiled. But the compile happens pretty fast, and you can still kind of access any one of these models. If you do want to get the code out of it, so remember we're using that C function that would just display the source code of the model. You can just extract the code as a character vector. So the model code for every model now is tucked away in that model object. And so if you wanted to get that out, you could do that, and you could just doesn't override anything. I can just dump that out to what does this do now? Anyways, I can write this out to the file. Let me see if, okay, 3 times the charm. So I can write this out to a file, that model code, and that should just be sitting right in your working directory, and then I can go in and start modifying that if I wanted to use that like as a template or something like that. Sorry, it took me so long to figure that out. Okay. So you can't install modmrg anymore. It won't work. But I think this is a simpler interface. It's consistent with what we use with just regular mrg solve, and it's probably more convenient. You don't have to access another package. And I think the only downside to this is that you don't get these models aren't like pre-compiled. But I think it's just kind of a small. It's just a very small inconvenience. And I'm not going to work. I've got this. Yeah, let's just pass on that. So it's about 12:30. So let's go on to the last topic, and this is kind of the bigger topic that I wanted to really demonstrate here, is talking about an annotated model specification. People have been asking for this feature for kind of several years, as when we long before we released mrg solve into the public domain, and we were talking about what we wanted to do with this. Especially with our larger systems pharmacology models that we do here in Metrum. It's nice to, when you get a lot of parameters and you kind of forget which one's which, and you want to provide some context around like what does a parameter actually do, or what is a compartment name, like getting some more context around the meanings of those symbols. And we finally got the parser, the mrg solve parser, to be kind of robust enough and kind of flexible enough where we could start parsing models that have annotations in them. And I'm going to show you how to turn a regular model into an annotated model, just to demonstrate the different kinds of the different syntax that we want to get at here. And I'll show you the kind of result first. So this is an HTML file that was made with R Markdown, and kind of so the end product that we're looking at here, that we want to get to, is this kind of like summary of what the model is. So there's a kind of a header here. This is just an example annotated model. We've got some information about the author and the date, and kind of some, if you're using this in a project work, you might put like, where did this model was spawned off from another model or something like that. And we've got some model details. So we describe all the parameters, the compartment. We've got the name of the symbol. We've got a description kind of in words of what that is. We've got a unit, and there's this options column that I haven't been using, but that's just other text that you can associate with each compartment or parameter or output variable. We can describe things in the omega matrix, what these different etas are, and then we can describe output variables, so stuff that we put into capture. We can say what that is, what the units are, and things like that. The other thing this gives you is kind of a listing of the parameters and the values. And then the same with the initial conditions. And then it'll just give you a listing of some of the model code. What's in $main, what's in this doesn't have an ODE, but it'll show you the ODEs. It'll show you a dollar table. So you can just get a quick view of what's going on with this model. So that's kind of like the end result. That's where we're heading. The next piece of this demonstration, I'm just going to take kind of this simple model that's in model.cpp, and I'm going to turn it into this annotated model that's going to look like this. So I'm going to try and do this on the fly, just so hopefully the coding makes a little bit more sense. Instead of just talking about it, I'm going to try and do it. So the model that I do here might not turn out exactly to be what you'll see in the repository, or what we'll build here. Okay, so one thing to notice is that this $prob, so that's kind of like $problem in non-mem. And previously that's just been kind of ad hoc text that you can make notes to yourself about what you did and when you did it and things like that. So $prob is going to be, it can still be just plain old text if you want it to be, but we're going to take that chunk and that's going to get rendered in Markdown. So what I've been doing is I've been you can write Markdown text, and when the model gets rendered, that'll get rendered like this. So this is going to be an annotated model. And you can do stuff like this, right? I'll probably botch this up because okay, I'm just going to leave it at that. And then you can just put other text in there if you want to. But lately I've just been making this to be like our Markdown lists and things like that, and it'll get evaluated when the model gets built, or when the file gets built. I've got some settings in here; those kind of stay the same. But a big part of this is going to be annotating the parameters, and I'm going to show you how to do that. So the first rule here is that these have to be 1 per line. So I'm going to put these down to be 1 per line. The first thing that comes is the name of the parameter, so clearance, and then we do a colon. We do the value, and then another colon, and this is going to be clearance. The unit is going to be in the parentheses. Same thing for volume. But volume value is 2. This is going to be in this KA. There's no really like spacing requirements on this, but I kind of found it's kind of neat if you can almost make this look like a Markdown table, and it just makes it. It seemed to me like it just makes it a little bit easier to read when you're just looking at the file. You can also do it with fixed. So fixed are just like param, except the values are fixed. You can't change them later on, but especially when that parameter list gets to be kind of big, kind of moving values out of that parameter list and making them fixed so they get declared as const doubles in the C file, and so you don't have to spend that time looking that up in this parameter vector. You can skip the units if you want to. You don't have to put them in there. But again, it's the pattern here is just the name, colon, value, colon, and then the description, parentheses, and the units. Theta doesn't have a name, so the whole purpose of this theta is it names it for you. So we got 3 theta values here. I guess a little bit bigger. So we got 3 theta values here, and the whole purpose of putting this in $theta is that it'll name these theta 1, theta 2, theta 3. So we don't want to mess with the names, and so what we do is we just do a description, DVCL. So it's just going to be 2 things. For the wait on clearance or whatever. And this next one is DVC maybe. This doesn't really fit in with a model specification I'm doing here, but I just want to do one of each. Just really the focus here is going to be on these blocks. Compartment, so kind of same idea. So when we do CMT, we only give it a name, and we don't put a value in there. And so the annotated version is, this is the dosing, so compartment, and that's in milligrams. We're expecting doses in milligrams. In it, that does have a value, so that gets to be a name value description. And I already forgot something pretty important here. Let's just go back and do it later. So for omega matrix, the way we annotate that, so this is a block matrix. So this is one more new thing that we need to talk about here, is that this is a new way to mark up, to add options to a block. So remember we had, when we had an omega matrix, we could say block equals true or core equals true, and that would just say, well, this isn't a diagonal matrix, this is a block matrix. And now we've got this at notation. And this was developed, Devin Pasteur at University of Maryland helped us kind of refine the syntax a little bit to make these options available. So when you say at core, that's kind of like a Boolean option. And then this just implies core equals true, or that it's going to be a correlation matrix. So off diagonals are correlation coefficients rather than covariances. And then when you have something like this, at labels, so this is at, this is the name, and these are the values here. So this just sets the labels for that omega matrix. The rules here is that, and it's kind of like we had the rules for the other ones, is that options occupy their own line, but you can put more than one option on a line. So when I put at core here, this reserves this entire line for options. So any data I have to put it on another line. So you can put it down here, or you can put it up here. Since I'm making this annotated, I'm going to get rid of the labels here. And the labels for this are going to go here. So it's going to be data on clearance, and then so it's just going to look like this. So you're going to kind of make this the lower triangle. So here's the variances here are 1 and 3 for clearance and volume. And then this first line here is going to be this is actually going to be the correlation coefficient, because we said block equals core. So if I had another one, it could be, so this would have to be, since this is a block matrix, I'm going to have to make this 3 elements long in there. It would be like that. And these are going to be, these are still going to be correlations, I guess. So I can make these or something like that. Dollar main doesn't get any annotation. Dollar table doesn't, but dollar capture does. So this is where we define, where we can mark up the output variables. We can say DV, and again, this is name and description, right? So there's really no value that goes in dollar capture. It just takes the value of that symbol. So that symbol has to exist somehow, and it just takes this. So this is the plasma. So again, it's just a name and a unit, and I could you could place more of them, but it's just gonna be a name and unit. So I'm gonna save this here. Kind of one really important thing that I forgot to do, kind of get going with this, is this. So when the parser goes through and works on this param block, it's going to think that it's like this is the old format. And I thought a little bit about trying to have this kind of guess the format, what you want to do here. But I ended up just making that a block option. So you have to write annotated. So with a new notation, it's going to be at annotated. That implies annotated equals true. And so every block that you want to have, we're going to have to make sure MRD knows that it's supposed to parse this as an annotated block. I hope someday that there will be like a kind of a global option to say, hey, make all these blocks annotated. I think So the kind of nice thing about having this be an option is that I can, or not like avoiding having it to be a global option, is that I can make another parameter block and I can make it not annotated, and I can say kn 50 equals 10. So I can add as many parameter blocks as I want. I can add as many compartment blocks as I want, and so all the blocks don't have to be annotated. So you can annotate the kind of the parameters that are kind of solid in your model. And when you're doing development, you don't need to add all the annotations when you want to just add a parameter to your model. You could add just another param block and it'll still get processed as a parameter, but it just won't show up in the annotations. So we'll see how many kind of mistakes I made here to see if this compiles. So I'm going to go back to this annotated.r. Actually, I'm going to take that out for now. Rats, this isn't going to work. Yeah, that's okay. So let's just compile this annotated.r. I'm going to have to comment this out because I kind of overwrote all that. So if you check out the repo to kind of work through these exercises, there's an annotated.cpp, and that's just a different file. That's the one that I pre-cooked that we were looking at the output for. And the one I'm going to do now, it might be a little bit different. But I'm going to keep that one in kind of pristine condition here, and I'm going to just try and compile that model file. Okay. So what I do? Oh, not too bad. So this says it couldn't see this identifier EV. The compiler was complaining, so I'm going to go back to model. Let's see what I did here. Oh, I call this EVC and not EV. So just to kind of go through again. So when you make this omega block, I can either specify the labels to make these ADAs to be ECL is like the ADA on clearance, EV is the ADA on volume, EKA is the ADA on KA. And I can either specify those as labels if I'm not doing an annotated block, but when I do an annotated block, these become the labels for that. And now when you run the model, you're going to get a symbol that's going to be either ECL or EV, and it's just a little bit more readable. And you can still have access to like ADA 1, ADA 2, and things like that. But I'm kind of encouraging everyone to use these labeled ADAs because it's just safer and it's just more readable and things like that. And we're really trying to get as much as we can to get away from numbering anything and have everything just be a symbol. And kind of we never need to remember what was first or what was second and things like that. Okay, so let's try this again. Cool, it compiled. And I can run this model and get the output. On the annotated models, so they don't affect anything with how your model runs. So the underlying code is really the same, and that's what I tried to show with this. Is I had a kind of an unannotated model, and I had the exact same model that was annotated, and you can show that you get the exact same kind of substance to the model. And that's so I can't run lines 16 and 17 here because I kind of undid that. So the way your model runs or the way it functions is going to be the same whether you annotate it or not. But when you have an annotated model, I can extract the details. So there's a function that's not exported so far. That's called details here. And let's just run it again. And this will just spit back like a data frame of all the annotations that you included in the model. So it'll tell you where the block came from. It'll tell you the name of the symbol, the description that you specified, and then it'll give you the units. So if you wanted to extract this and kind of put it into a report or do something else with it, take it apart. It's just a regular R data frame that just gets carried around with the model. So you can always extract this and kind of either look at it or do something else with it. So I kind of see the value in these annotations to be either I want to look at this and kind of remind myself what happened, But I think also it kind of helps a little bit to when you go back into the model code and you're kind of just looking at the code, it kind of adds some context around this. So the context is kind of interweaved in with the names and the values. There's kind of an informative description. I think kind of the downside to this, I don't usually do these annotations when I'm developing a model because it's just a lot more text to look at. And sometimes you just want to be able to look at the symbol and the value. And I think there's definitely more clutter to the control stream. So if you're kind of actively working on a model, I can see why if you wouldn't want to have this in there just to avoid the clutter sometimes. But for a model that's kind of finalized and you're just really using it a lot, I mean, it might make sense to add these annotations to provide this context, either for yourself or if you're passing it off to a colleague for them to run. Okay, so annotated. And so like kind of the, so that the next step that you can do is that you can render this model specification file into that HTML document that we looked at at the beginning. And so I've got a function called render that's inside the MRDSolve namespace. And this will always be inside that namespace because it's going to call our markdown render. And this just says there's a flavor of render that's specific to MRDSolve. And so I can either take this model and pass this into render, and that'll take that and it'll basically run like a template. A template, our markdown file, that it knows what to do with these different model components, and it'll basically spit out this. It just spit this out. It'll spit out this document that we said. So it'll take everything in $prob that we set up, and it'll render that like this. It'll give us just this data frame of the details that we can look up. It'll, again, dumping out the parameters and the values, and it'll dump out the code and things like that. Sorry, this wasn't, so this actually wouldn't go to annotated. What we actually did will go into so the output is going to be the model stem.html or .pdf, depending on how you rendered it. So this is actually what we just did. So this is that kind of this junky one that we did. But you can see the template is the same, and you get the same types of things. And I think the template is going to need some work, and there will be you can pass in your own template. So there's some requirements for the templates, but you could even create your own template to render your own models, and just say, so there's a template that's inside MRDSolve right now. You can easily pass in your own template to say have it render however you want it to. But there's always this kind of default template here. And I wanted to show one more thing here. And this is actually something I was thinking about, like actually on the way into work today. And I just implemented it really quickly this morning. And this is in only just absolutely the most recent version. So if you checked out before like 10 a.m. Eastern today, you can't do this. So I thought of adding like $1 demo block that's just like a bunch of R code that would show how to like run the model. But I thought we could put this into this $. Problem here, so we can our equals true. So in the template, all the blocks are echo equals false. And when you run this block like this, you can get the model object. Let's say there's like a special dosing regimen that you kind of like to use for this. You can put it in here. Well, 3. So I'm going to try and compile this. This should, so let me compile this and to see what happens. Details. I wasn't supposed to do that. Let's see. Oh, I see. Yeah. I just didn't code something here right. So I'm going to go back into the model. And I wonder why this didn't work. And I do. I'm just going to simulate some kind of regimen and put it in here. Go back to my annotated. So I've got to read in this model, compiles it, and it's done. So this gave us an error. It says the model is not properly loaded, so we can't like actually run the model. So there's an argument called compile. So this renders okay, and this basically allows you to put like a little like vignette, like a usage vignette into this. So it'll kind of show you that dollar problem, and you can include some code that'll get evaluated, and you'll see the output. So this is a way to maybe put some examples for how to run the model, or set it up right, or maybe there's a dosing conversion that you need to make or something like that. But when people are reviewing the model, they can at least see an example of how to run the model that might help them get started or something like that, and it'll render the output just like you would in any other R Markdown document. And so the trick here is just when the model renders, it doesn't compile the model by default because it doesn't need to unless you actually run something in the model. It just needs to get at what are the parameters or what are the annotations and things like that. So it kind of saves that compile step. And so if you want to include some demo code in that dollar problem, you just need to include this compile equals true argument, and then it'll actually compile the model. And I guess the other kind of assumption here is that the model, when you do write this code, this model will be available as mod. So you can't actually compile your model, the model yourself. You have to let the template compile it, and this will just be available for you to use. So I thought it was just kind of a nice way to just kind of wrap this up, to include some kind of details about the model, include potentially some demo code, and then providing these model annotations that will hopefully kind of facilitate model sharing between other MRG Solve users, or just to remind yourself, or you're handing the model off to a colleague who's going to pick it up on the project, and it provides some context about kind of what you did and things like that. I've been following a lot of the DD Moore stuff, and a question that we get a lot is, well, how is this different than what DD Moore is doing? And I think it is different. So I don't see it as at all as any kind of DD Moore replacement or use this instead of DD Moore. And I think that maybe the DD Moore guys can speak a little bit more about it, kind of how they envision DD Moore. But my kind of takeaway so far has been, it's really been interoperability and kind of model sharing are the kind of the goals, or I don't know if they're sub goals or they're kind of linked in somehow, and maybe they have other goals. I think that these annotated models kind of help us reach a goal of facilitating like model sharing. So this kind of hopefully helps you share a model, because you can just pass off the control stream to another MRD Solve user, and it's hopefully more reproducible or more intelligible what the model is doing. But this does nothing for interoperability. So this won't help you at all to get your model into another, into non-mem or into anything else like that. And so we totally haven't at all gotten into that. So that's gonna, in my mind, that's a big piece of what DD Moore is doing. And so it doesn't help that at all. And I think we've talked about getting into DD Moore and things like that. And I think we want to, as soon as that becomes available on a more kind of neutral platform. And I could see us linking in with the MDL language and things like that, and getting a converter from MDL to MRD Solve. But this is really like a intra tool kind of feature. This is for people that are using MRD Solve, and they know that they're going to be using MRD Solve. Okay, that's all I had to show today. I think we're still 5 minutes before 1, so even with the big delay getting started, again, I apologize for anyone that had a hard time finding the link, or were joining us late. Thanks for your patience with the link again. I appreciate it. I hope that this so far, I hope this has been helpful. Demonstration. I'm just going to stop the screen share really quick, and or actually, I'm going to go see if I can find any. Rena, can you just look on the discuss forum to see if there's any questions that came up, and I can try and answer them. I think you're stuck looking at maybe my ugly mug until then. But we could, if you have a question and you want to post it really quick on the discuss forum, we can try and see if we can get them to come through. Otherwise, post questions or comments or anything either on the discuss forum, or if you want to get involved with the development of this. I mean, all the annotated stuff is pretty new. We're hoping that people will use it and start finding kind of either problems or deficiencies or things that they like, and we can continue to refine how this works and makes it better. So please don't hesitate to get on the GitHub site and give your feedback or put in bug reports and things like that. And we're kind of interested in improving this and kind of making it really useful and really helpful. But the other thing I'll mention is that we'll be at ACOP in a couple weeks. Michelle Johnson, who is our communications person, she's been tweeting about this, and she's going to send this out as a flyer. Is that we're going to try doing this MRD Solve office hours at ACOP. So if you want to, if you're an MRD Solve user and you're working on a model, or you just need help getting installed, or if you're just need some advice, you can come by our booth and sign up for an office hour, and I'll sit down with you and kind of talk with you about how you're using MRD Solve, or give you some advice or things like that. We really wanted to just meet people who are using MRD Solve, see how they're using it, like help them kind of solve problems that they're encountering in the modeling. So look for that coming through on social media or through our newsletter that's coming through, or just stop by our booth and find a time, and we'd like to talk to you and just see, kind of help you solve problems, or just talk to you about how you're using MRD Solve. So look for that MRD Solve office hours.
There's one question about how would you envision individuals helping out? I guess push the
helping out with
forward, or
Oh, yeah. So the question was how do you envision individuals helping out with the development? Yeah, so we have the code listed the code is hosted on GitHub, and so if you make a GitHub account, you can fork the repository, and there should be a lot of tutorial stuff on the GitHub site for how to do this. But basically, you make a copy of the repository, you make changes or to your fork, so your copy of that repository, and then you can make a pull request to merge it back in, and we review the pull requests and things like that. So there's a whole process for collaborating on GitHub. If you wanted to just make suggestions or say, I'd like it to look like this, or I think this behavior is wrong, I mean, you can just, all it takes is just making a GitHub account and then just post it on the issue tracker, make a feature request, or make some request to change, and write how you'd like it to look, or what your suggestions are, and we take those up, and then we can actually do the development. But we've certainly had other people, not a lot, but we're certainly open to pull requests through the GitHub site and through that whole process. Okay, that's it. We'll call it a session. Thanks everyone who came, and for your attention and for joining. And we'll see you either at ACAP or down the road in the study group. Thanks again, everybody. Bye.